The way that we measure atmospheric pressure, air pressure, is through a device that we call a barometer. And just very quickly, the way that a barometer works can be illustrated by looking at a crude mercury barometer, one in which there is a container at the bottom where there is a pool of mercury that's exposed to the air, and then there is an inverted column of mercury that's supported by this air pressure, so that when the air pressure increases, it is going to push down on the exposed mercury. There is very little compression in the mercury, so the only place for it to go is up that inverted tube, and we can see the level rise. So as the atmospheric pressure rises, so does the level of the mercury in the tube. If the air pressure is to decrease, it's not going to be able to support as much mercury, and so the mercury level will drop, and the mercury level in the tub will rise, and so what we will see is the lowering of that level to correspond with a lower atmospheric pressure. Now, because this is mercury and because these increments are moving down by millimeters, or can be measured as moving down by millimeters, one of the ways that we can measure atmospheric pressure changes is in millimeters of mercury. However, this is not the standard unit that we use for pressure. The standard unit that we use is kilopascals, or more accurately pascals, but we use kilopascals. But all of these pressure units can be converted between, and you are going to come across a few. You might come across atmospheres, or you might come across torr, but there are conversions for all of these units. So torr and millimeters of mercury are the same, but every 760 millimeters of mercury is equal to 1 atmosphere, which is equal to 101.3 kilopascals. So really, as long as you have your conversion skills, you can convert between any one of these pressure units. So now you have all the tools that you need to explain how a straw works. Thanks for watching. No? Not quite? Well, I guess I got some time. We can work through this. Okay, did you understand how a barometer worked? Well, I can't hear you, so I'm going to assume that you kind of understood how a barometer worked. Well, if we understand pressure, and we understand how a barometer works, even a little bit, we can probably start to explain how a straw works. And if we think about a straw as we put it into a liquid, and just leave it there, what you're going to notice is that the level of liquid in the straw, that is in the plastic cylinder that represents our straw, and in the cup that holds the liquid, those levels of liquid are going to be the same. And the straw itself, above that level of liquid, is going to be filled with air, and the container itself is going to be filled with air, and the air inside the straw and the air inside the liquid container is probably the same pressure. So the liquid levels are going to be the same. Now, when you put your mouth over the straw and close your mouth over the straw, you're creating a seal. Now, you're not sucking here. Remember, nothing sucks in science. But what you are doing is breathing in. And by breathing in, you're expanding your thoracic cavity, your chest cavity, your lungs get larger. The volume of the lungs get larger. Now, what do you think happens to the pressure of the air that's in your lungs if the volume gets larger? Now, we're going to talk about this a little more when we get into gas laws, but I think you already understand this relationship. As the volume of air gets larger, or the volume of your lungs gets larger, the pressure in your lungs goes down. Now, if the pressure in your lung goes down, the pressure of the air in the straw is now greater than the pressure of the air in your lungs, and so gases, and air, being a gas, will move from areas of high pressure to low pressure. Think about a balloon. If you have a balloon and you blow it up, what do we know about the pressure of the air inside the balloon versus outside the balloon? Well, if you let it go, you're going to find out. Air moves from areas of high pressure to low pressure. And so as a result, the air moves from the straw into your lungs. But now, there is less air in that straw, less pressure in that straw. Outside the straw, the air pressure is acting on the surface of that liquid. And so what happens is that that air pressure, which is now greater than the pressure inside the straw, pushes that liquid down, just like our liquid barometer. And what happens is, since that liquid has a low compressibility, it is going to go up the straw and into your mouth. And if you think about this, think about having a broken straw, or think about trying to suck through a straw without completing a seal around the straw. It doesn't work very well, does it? That's because air rushes in and equalizes the pressure so that the liquid cannot be forced up the straw. Do you have a better idea of how a straw works now?